Today's computer science. This one will be an interesting one actually because uh, I don't know. This course might have existed when I was a kid, but we certainly didn't have it in my school, and I don't think it existed. I'm not sure. Um, so as a computer scientist myself, I'm going to be interested to see what they actually get taught at GCSE because I only did computer science at master's level onwards. My bachelor's wasn't even in computer science, it was in maths. So I jumped in right at the deep end. Um, okay, let me just put the. We don't need to look at this spreadsheet right now. So the paper. I don't think I'm gonna need my pen for this one. I think it's gonna be. I can do it with. Oh, let's not look at that. Typing. So, well, we can use the pen to fill this out. Let's just do that. Okay. Uh, oh, it's upside down. That's why. So we are. Five. And then at number 2, for no particular reason. Okay, so computation. Okay, so there's 2 papers. Paper 1 is computational thinking and problem solving, and the second paper, I don't know what that's about. It might involve more programming. So this might be more akin to IT. I'm not sure. And there might be some multiple choice questions. Whatever format you prefer for coding, as long as your meaning is clear and unambiguous. Good. Must not use a calculator. Cool. Cool, cool. Alright then, I guess I'm ready. So let's start the timer. How long? 1 hour 30. Alright, begin. A bitmap image is okay. You know what? I'm gonna unplug the pen until I need it. So a bitmap image is represented as a grid of pixels. State what is meant by the term pixel. Triplets. Are you serious? Did I just get disconnected? Alright, well I have a backup recording anyway. An RGB triplet of values 0 to 255, representing a visual color. Comprised of 3 primary colors. Is that what pixel is? Okay. State the maximum number of different colors that can be used if a bitmap image has a color depth of 6 bits. So 2 to the 6, which is 64. And normally we use 8 bits, 16 bits. Nowadays, I think. Alright, so what is the minimum file size for an 800 pixel by 1000 pixel bitmap image that uses 20 different colors? Coffee. Technically, you're not really allowed to drink coffee during a GCSE exam. Well, actually, I don't know. I don't think you... Oh, it wouldn't be normal. But then... It wouldn't be serving coffee at the school then. In the exam. Minimum file size for an 800 pixel by 1000 pixels. Okay. So... So it's 800,000 pixels. Each pixel therefore you have 20 times 800,000, which is what, 16 mil? Hang on. 1,600. 16 mil. Hang on, no. Different colors. So that's... Wait, I don't understand. That need... Okay, oh, I see. Okay. So that means we need... Means... 2 to the 5 bits per pixel. Because if you had 4 bits, you would have 16. That wouldn't be enough. So 5 bits per pixel. So you would have 4 bits altogether. Which is about 4. Hang on. I'm taking too long on this question, aren't I? I've forgotten all this basic stuff. All right, for that is what in bytes? You divide by 8, right? So 500,000 bytes. 500 kilobytes, roughly, because it's you actually divide by 1024. So let's say that's the answer. I don't need to put it down there. Okay, 500 kilobytes. All right, the algorithm shown in Figure 1 converts binary data entered as a string by the user into a representation of a black and white image. The algorithm uses the plus operator to concatenate 2 strings. Complete the trace table. What is a trace table? It's just like a memory state. Okay. So I at the start is 0. What the heck? Okay, don't use tab. And image is just that. Is that a space? No, it's an empty string. Okay. So for I equals 0. No, but yeah, but when are we looking at image? Before or after? Because probably after the one loop is done, at the end of this loop. So let's say, so if we start with empty, if b data 0 is 0, okay, that's not, no. B data, B data is the first character is 1. So we go to the else. Image, take image plus /. So we append a /. If I mod 3 equals 2, then output image. I see. I'm getting it now. Okay. So now we go to I equals 1. So image is what it was before. So now it's a 0. No, it's a 1. So we put another /. Okay. And 2. It still doesn't make sense because there's 2. I think we're supposed to show the state changes every time either one changes. So the very start, we start with this, just empty. And then we get /. That becomes 0, we get /. Then that becomes 1, we get 2 slashes. Then that becomes 2, and we get /*. But then it becomes wiped because it's 2 mod 3. Then when we get to 3, we just repeat. So we do // asterisk /*/, and then it gets wiped. So ultimately you get that // and then you get that /*/ outputted. Is that what they want? I don't know. Describe how the linear search algorithm works. I assume you just iterate through each value in list, compare against candidate if equal, halt loop and output located item. If equal comparison. Is that what they mean? Okay. We don't... State the name of the logic gate represented by the following truth table. So it's one if and only if both A and B, so it's an AND gate. Also, they study circuits in this course. Keyboard A and keyboard B. And either one can be connected to a computer system. If they are both connected, then the computer system will not work. Output P has value 1 if either keyboard A or keyboard B, but not both, is connected to the computer system, and 0 otherwise. So XOR is what we're doing. Oh, what the... Aren't they overcomplicating this? Why do you need all these logic gates? So you want it to be 1 if either A or B, but not both. Why have I disconnected again? Alright, it's reconnecting. I don't know what is wrong with Twitch today. I've heard there's all sorts of problems going on with Twitch. Apparently, a lot of people are not able to chat, or at least they need to verify their phone number to chat, even though the streamer hasn't set that. So I think there's some weird Twitch bugs. Okay, so what logic gates do I want? What is going on here? So if A and not B. Okay, so L3 we probably want an AND. Okay. And L4 we probably want an OR. And then what do we put to fill the rest? Oh, easy. It's symmetric, isn't it? So it's L1, we want a NOT. L2, we want an AND. But yeah, that's it. All right. Yeah, algorithm shown in figure 3 is used to check if the start of an instruction for a particular assembly language is valid. String representation of the assembly language instruction is stored in the value inst. Characters in the string are indexed starting at 0. Yeah, okay. Shade 1 lozenge to show the most appropriate data type of the variable I in the algorithm in figure 3. Integer. That's pretty clear. State the data type of the variable valid. Well, that's going to be a Boolean, isn't it? State the final value of the variable valid in the algorithm figure 3 for the following different starting values of inst. Add R0, R1. All right, let's have a look at this algorithm then. So it's saying while we haven't hit the colon, and I is less than 4. We take each letter from the instruction and put it into code. Okay, so we take the first 3 characters, first 4 characters even, and stop if we hit a colon. Put valid to false. And if we extracted add or sub or halt before hitting a colon, valid is true. Okay, so I can see that this one here is correct because we'll stop at the colon. Halt, I believe, is true because, hang on, 0, 1, 0, 1, 2, 3, and then we'll stop. So this is true, but this one is false because we will capture the space after the add, which we shouldn't. Well, there'll be an extra space, and so it won't be equal to add. So it will remain false. All right. State what an assembly language program must be translated into before it can be executed by a computer. Machine code. State 2 reasons why a programmer who can program in both high-level and low-level languages would usually choose to develop in a high-level language rather than a low-level language. Less time needed to write code. I mean, better type safety or something? No, wait, that wouldn't. That's not necessarily true. Code is more readable. Develop an algorithm using either pseudocode or a flowchart that initializes a variable called red, valid to false. Okay. Okay, so reg valid equals false. Sets a variable called reg valid to true if the string contained in the variable reg, if the string contained in the variable reg is an uppercase R followed by the character representation of a single numeric digit. If, so we want if, can we check the length of the string? Because otherwise we're going to access invalid characters. If length, I assume I'm allowed to do this. Reg equals 2. I'm going to write this in Python style. If reg 0 equals R, if is digit reg 1, valid equals true. That's it, right? If is 2 characters. They don't mean it's valid if there's more than 2 characters, do they? They don't explicitly say, but I think that's implied. So if there's 2 characters, the first one's R, the second one is a digit. Yeah, okay. The algorithms shown in figure 4 and figure 5 both have the same purpose. Left shift performs a binary shift to left by the number indicated. For example, 6 left shift 1 yeah, okay. Complete the trace table for the algorithm shown in figure 4 when the initial value of number is 4. Okay. So it's 4, then it's eight times by 2, and then you subtract 4. Hang on. Result doesn't start at 4. Number starts at 4. Results, the first value of result will be 8, and then you subtract number, so you get 4. And then it finishes. Okay. Complete the trace table for the algorithm shown in figure 5 with the initial value of numbers 4. Okay. So we've got x1 result becomes, oh no, hang on. I don't understand these trace tables. Okay, so x doesn't have a value to begin with, and result is 0. Then we got 1, but result is still 0. Then result equals result plus number. Okay, so x stays 1, result will be 4. Then we've got 2 and 4. Then we add another 4, so we get 8. Then we got 3 and 8. And then result will have 4 added to it, so it's 12. But you get different results. This one gives you result 12, and this one gives you result 4. Oh, left shift 2. Damn it. So it's 16. And then result minus 4 is 12. There we go. So what is the purpose? What is this? You're multiplying by 4. You're multiplying by 3. Explain why the algorithm shown in figure 4 can be considered to be more efficient algorithm than the algorithm shown in figure 5. Because it uses left shifts, which are more efficient. So it does left shift and then a subtraction, whereas figure 5 does 3 additions. The left shift operation is more efficient than the arithmetic operations performed in figure 5. One left shift and 1 subtraction versus 3 additions. Show the steps involved for either the bubble sort algorithm or the merge sort algorithm to sort the array shown in figure 6. So the result is 1, 4, 5, 8. Circle the algorithm. Well, I don't like bubble sort, but it might be easier to write it out the steps. No, it'll be more steps, won't it? Okay, let's do merge sort. So L1 equals partition array into L1, L2. Eight, 4, L2 equals 1, 5. Perform merge sort as subroutine on L1. L1 1 equals 8. L1 2 equals 4. Merge L1 equals 4, 8. Perform merge sort recursively on L2. So just do the same thing. L2 1 equals 1. L2 2 equals 5. L2 is 1, 5. Merge L1 with L2. So we take 1 from each. So we take 1, then the 4, then 5, then the 8. There. Four subroutines are shown in figure 7. Dear. Okay. Complete the table showing all of the outputs from the subroutine call main3. The first output has already been written in the trace table. You may not need to use all rows of the tables. Output 3. So we're using main with k equals 3. Okay, so output 3. Alright, so put 3. And while k is greater than 1, if is even k is true, that's not the case. So we go to the else. K, we increment k, right? 3 times n plus 1. So we go to 10. Increase k 3 times k. So k is now 10. Output that. Okay. Now k is still bigger than 1, and it is even. Then k will become decrease k, so divide by 2. 5? Wait, it was div. Assume just normal integer division, so it's 5. Output. It's still greater than 1, so increase k, so it'll be 16. Output. And now it'll just keep halving, won't it? So 8, 4, 2, 1. And when it's 1, we exit the while. But 1 doesn't get outputted. Oh no, it does, because it got outputted previously. Yeah. See. Describe how the developer has used a structured approach to programming in Figure 7. What did I mean by structured approach? I don't know. Effective use of subroutines to separate out the individual functions, avoiding one routine doing too many things. I don't know. Two marks. Structured approach. I mean, what more can you say than that? Subroutines are given names to describe the semantic meaning of their function. Subroutine code to car can be used to convert a character code into the corresponding Unicode character, for example. Shade 1 lozenge to show what value will be returned from the subroutine called code to car 95. Code to car 100. So 97 is A, 98 is B, 99 is C, 100 is D. State the value that will be returned from the subroutine call. Okay, so car to code E. So car to code A is 65. So B 66, C 67, D 68, E 69. That's 69 there. Plus 2, 71. Code to car. So you're just going up by 2 letters. So yeah, G. Write the subroutine to lower using either pseudocode or flowchart that takes an uppercase character as a parameter and returns the corresponding lowercase character. For example, if the subroutine to lower is passed the character A as a parameter, the subroutine should return the character A. Okay. So it's just, okay, so we got, we take a character, okay, so eventually we want code to car, and then we'll take car to code of let's call it car. So now we've got the code of the uppercase character. And we just add 32. Plus 32. And then convert it back to a character. That's it. Five marks? No, what? How am I supposed to get 5 marks out of that? I don't... Whatever. We'll see what the marking scheme says about that. 5 marks? Seriously? A developer needs to store data about thousands of songs in a program. She needs to be able to hold information on every song's title, singer, and year of release. Explain how the developer could use a combination of an array and records to store this information. In your answer, you should refer to the data types that would be used by the developer. What? Combination of an array and records. Record. Structure consisting of a unique ID as an integer, title, which is a string, singer, which is a string, year, which is an integer, the developer creates an array containing a single record for each song indexed by the ID value. What more can you say? How do you get 4 marks out of this? I feel like these are questions that students have been taught precisely how they're supposed to answer. I don't know what they want. An application allows only 2 users to log in. Gower. Their usernames are stated in table 1 along with their password. Develop an algorithm using pseudocode or flowchart that authenticates the user. The algorithm should get the user to enter their username and password. 6 marks, alright. say authenticate. Authenticate. Username equals get input. I don't know. Ah, okay, I see. So while true. Password equals get input. For I from 0 to 1. So start by saying authenticated is false and go through each table entry. If username is do I need to hard code? Oh, I don't know. Should I just hard code Gower and tough and all that? So I say if username is equal to Gower and password is equal to 9FTG3, or username equals tough and password equals 888RG, but access granted. What the? Where was I? And while else that's it basically. We could also say 6 marks. All right. Develop an algorithm using either pseudocode or flowchart that helps an ice cream seller in a hot country calculate how many ice creams they are likely to sell on a particular day. What? 9 marks? How many more questions do we have? Not many. All right. Get the user to enter whether it is the weekend, weekday. All right, so is it the weekend? Y or N? If in is Y, weekend equals true, else weekend equals false. All right, so that handles the weekend. Get the user to enter the temperature forecast. Okay. Output. Enter temp forecast. Temp. So forecast equals zero, let's say. While forecast, while not $20 is less than or equal to forecast is less than or equal to 45. In degrees Celsius between 20 to 45 inclusive. Okay, so we've captured the forecast now. Calculate the number of ice creams that are likely to be sold using the following information. Okay. If 20 less or equal to forecast, then equal to 30 num sold equals 100. Else, if $31 less or equal to forecast is less or equal to 38, num sold equals 150. Else, num sold equals 120. So if it's even hotter than that, no one's going to be out of the house, basically. 45 degrees, wow. That's Saudi Arabia levels. All right, so that was when I lived in Saudi, that was just every day of the year. I didn't eat much ice cream there though, because the ice cream would just melt. That's why you don't get ice cream when it's too hot. That's the reason. So it's the peak is between 31 and 38. So if we can, it's true, num sold equals num sold times 2, so double it. That's it. Hopefully that'll get us 9 marks. I mean, we basically just said what they've said. Developers original set of subroutines to control an array of lights. The lights are indexed from 0. They are controlled using the subroutines in table 2. Alright. If the starting array of lights is on, off, off, on, off, off, on, what will the array of lights become after the following algorithm has been followed? So A is 2. Switch A. Okay, so let's look at switch. So you basically switch it. Okay, so switch A. So it's on. Okay, right. Okay. Switch A plus 1. So that's. So let's just use an arrow. That's on. That is now off. Neighbor A minus 2. What's neighbor? If the light. So neighbor of n. If the next one is on, then you set this one on. So if the one to the right of you is on, then you set this one on. If the one is off, you set this one to off. So you copy whatever is to the right of you. So here, A minus 2 is 0. So this should be off. Right, so it should be off, off, on, off, 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 on. If the starting array of lights is that, what will the array of lights become after the following algorithm has been followed? For A from 0 to 2, switch A. Okay. So that is now... So these are all switched. So that's on, off. B is 8. Range off. Okay, so let's have a look at range off. Range off. All the lights between M and N, but not including M and N, are set to off. Alright, so range up. So B over 2 is 4. So basically, just light 5 is off. Okay. Neighbor B minus 4. B, what was B? B is 4. So 0 copies whatever 1 is. So that's nothing happens. Right, so it should be on. This is a bit odd. The range off only changes 1. Is this really what was meant to happen? Probably. Neighbor doesn't do anything. Okay. If starting array of lights is that, what will the array of lights become after the following algorithm has been followed? So A is 0. While A is... Okay, I have to make some notes here. A is 0. A is 0. While A is less than 3, switch A. Right, so that's now on. B is 5. While B is less than or equal to 6, switch B. Alright, so switch B. So B is 5, so switch that one off. And now increase B, so it's now 6. Switch B. Okay, so turn that one on. Now it's 7. So end the while. A is incremented to 1. Now we do this again. So switch A. So that goes off. B is 5. So this just repeats. So now this gets undone. It's a bit weird. I see. So then for 2, that gets on, and then this gets done one more time. And then A is 3. All right. So what are we on? So basically just does off, on, stays on, that stays off, and then these two are flipped. So off, on. Oh man, more of these, really? The starting array of lights is this. Write an algorithm using exactly 3 subroutine calls. That means the final array of lights will be off. You must use each of the subroutines switch, neighbor, and major. What is this? This is just a weird puzzle. This is not... Okay, I mean, easy enough. We just do... switch 1. So that switches 1 off. Neighbor 0. So that switches 0 off because it's copying 1. And then range of 1, 7. So that'll do 2, 3, 4, 5, 6 off. Done. Okay, that was my first experience with GCSE computer science. It's a bit odd, or at least, I mean, the questions are sensible. It's just, I get the feeling they have some really specific answers in mind. I'm worried that I didn't do what they wanted. I've still got loads of time. I don't really feel like checking my answers thoroughly. It's just boring. All right, let's just quickly look through. Yeah, I was pretty happy with, okay, was that right? 800,000. Yeah, because we don't have calculators, so I can't divide by 1024. This was weird. Hang on. So we said I is 0, image is nothing. That's correct. Then image changes, but I doesn't. So we're showing every time either of these changes what it looks like, right? So 0 /. Yeah, so this isn't quite right. Well, I mean, if I'm following this pattern, then I need to say this is now 1 without changing the /. And then we add the slash. Then 2 without changing. See, I don't know if I'm doing this right. And then 2 changes, and then 2 changes again. And then we've got 3 with just empty. And then 3 with a slash. Then 4 with a slash. Then 4 with a slash and asterisk. Then 5. See, this is what I think it should be. I'm worried they're going to dock me marks for this. Because this is every possible pair of states at any point during the algorithm. It's covered here. 5, it's emptied, and then that's it. And the output, we don't need to say. Two reasons why programmer would use high level. More readable, which is good for code reviews and stuff. Less time needed to write code. That's true, right? It's true for me. That's why I use Python. I think this was fine. They had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows here. 1, 2, 3. Yeah, that's fine. I don't know. I don't really know what to do for this question. Structured approach. Should I say something a bit more technical? Doing too much business logic. So you add 2, so you go E, F, G. Yeah, easy enough. 5 marks for this? I don't see any way. I mean, this is what I would write, right? I wouldn't write it in some overly complicated way where you... I don't know. Flowchart. Actually, flowchart is reasonable as well. Yeah, what more can I say here? I don't really want to check through my answers because I'm too lazy. So I guess we'll end there. All right then. See what I got. I'm worried actually. Right then. So we've got the mark scheme. What weird annotations? So semicolon means single mark. I'll try to use common sense here. All right, let's have a look. Bitmap image is represented by so a pixel representing a visual color. Okay. Smallest part of an image. I mean, the fact that it's smallest is not the important point. But I think there's only one mark, so I've said color, I've said... I don't even know if I've got this mark. I think yes, because I mentioned that it's a color, and they said color. They seem to be emphasizing the fact that it's the smallest part of an image. It doesn't have to be. That's not the important point of a pixel. Picture element. Picture element. I think what I've said can be interpreted as a color, as a picture element. Right, I'll give the mark, but I don't know about that one. That's correct. $500 kilobytes, yeah. Max 2 marks if any additional value is given. Come on. But all right, let's just make sure we go. Okay, we get 2 marks, but what? Why wouldn't you have 0 and empty string? Because that is also a trace. That is also happens. So why is 0 / the important one? From the perspective of code, there's no meaning to this. It's just values changing, right? So there's one set of values that 0 and image have, I and image have. There's another one that I and image have. And neither is more important. So why would I choose 0/ and not 0 string to show in the trace table? I don't know. Or maybe there's some special meaning of trace table, like it's every time you loop or something. I don't know. Okay, well, I'll obey the mark schemes. Let's see. We got the slash, the double slash, and the double slash, and then the slash, and then the slash asterisk, and the slash asterisk slash. So we've got 2 marks. Because apparently... I can't even think what argument could be used to say that you should keep these ones and not the other ones. So let's keep track of marks lost. It's an easier way to do it. Lost 1 mark so far. Describe how the linear search algorithm works. Start at the beginning, compare each element. Yeah. AND gate. So it's not and or. Not and or. Got it. Integer and then Boolean. Yep. Bool? What was it? A bool? False, true, true. False, true, true. Machine code. Alright, this one I don't know what reasons they're expecting here. Easier to understand, read. I would say, yeah, readable, definitely. And shorter. Well, no, I said less time needed to write code. Which I would argue is the same as saying shorter, but... And they also say any other correct justification, so I would say that's correct. I mean, you don't care about... Ultimately, what you really care about is time. You're being paid by the hour or whatever, so you want everything... So I would argue mine is more correct. It doesn't matter if the code is shorter if it takes longer to write. Alright. Reg valid false. So I didn't really need to check the length. Apparently that's just assumed to be correct. If it's R and is digit reg 1, then reg valid true. So that was the core. (16.2) and then, okay, let's have a look at this. (0, 4, 8, 12). If more values are given in any column, then max 1 mark. Another, whatever. So we get 1 mark. But we do get this. I do not understand trace tables, and I don't even think they're a good way of understanding algorithms. Well, I understand the concept behind a trace table, but the fact that you're not rewarding me for showing the full trace... Well, we lost 1 mark. Multiply number by 3. Fewer variables, fewer instructions. One left shift and one... Okay. I mean, I think it's important that they're using the binary shifts, because that's efficient. You know what's really interesting? They say here the algorithm in figure 4 will execute in less time. That is literally just saying it's more efficient. So you're saying, explain why figure 4 is more efficient, and your answer is, it's more efficient. They're actually accepting that, basically. Well, I think... Well, I have pointed out that there's fewer instructions. I've said 2 on the left and 3 on the right, so that... I don't know why they're not interested in the point about binary shifts being more efficient than other arithmetic operations. Okay. So I've gone with merge sort here. So 8415, 8415, and then we split them into the individuals. Yep, I did that. Then we get 4815 and then 1458. Nice. All right. 3, 10, 5, 16, 8, 4, 2, 1. Perfect. All right, I'm happy so far. I actually got marks I wasn't sure if I'd get. All right. Modularize their code, use subroutines. That's the first mark. The developer has decomposed the problem into sub-problems. So the naming doesn't matter, apparently. But I guess I can agree with that. Use return values, use local variables? I wouldn't think that this is an important part of structured approach. That's just programming, full stop. Like, you always use parameters. In what approach to programming would you not use parameters? Alright, I think my first 2 clauses, use of subroutines, separate out functions, hit these 2 lines, used subroutines. Okay, I definitely got that one. And decompose the problem, broken the problem down into sub-problems. I would argue that is a rephrasing of separate out the individual functions. I think that's fair. All right, D. G. Right, this one's 5 marks. Using either pseudocode or flowchart. Two lower and 1 parameter. Did that. Using character code with a variable parameter. Yep. Adding 32. Yep. Using the result of C as a parameter to... Yeah. Returning the value of... Yeah. 5 marks. Nice, easy 5 marks there. We do it as a flowchart. Okay, this one, I don't know. 1 mark for one of the following, 2 marks for all 3. Alright, so... Hang on, start from the stop. A record could be used to store the data of 1 song. I didn't really... Yeah. Single record for each song. I did say that. Okay. An array could store all of the records. Yes, I said an array containing a record for each song. So that's the array containing the records. Yeah. 1 mark for one of the following, 2 marks for all 3. So I have to say subtitle string, singer string, year of release, integer, or date. Yeah. Yeah, I got those. Okay. Username, user input, password, user input, until. It's until. Okay, I've done that, but with using while. User equals Gower and password, or using as tough output access granted. Yeah, I've done that. Oh, okay, let's look at these marks. User input to a variable. Yep. User input to a password. Use a different name for it as well. Yeah, I did. Using indefinite iteration and including user input within the iteration structure. What? Indefinite iteration. Okay, mark D for using a Boolean condition. Yep. Mark E for using the Boolean OR operator for both combinations of using. Yep. Mark F for outputting the string. Yep. So what the heck is C? Oh, I think that's the while loop. Oh, okay. Yep, I got it. Nine marks for this. All right, mark A for assigning user input to a variable, weekend or weekday. Yep. Mark B for assigning user input to a variable, temperature. Yep, forecast. Mark C for using indefinite iteration to repeatedly input the temperature. Yep. Mark D for Boolean check 20 to 45. Yep. Mark E for using selection to set ice creams to be 100 if the selection. Okay, if else basically. Yep. Didn't really need to check 20. But it doesn't matter. Num sort is 100. Mark F, 150. Yep. Mark G, 120. Mark H, doubling if it's a weekend. Yep. Mark I for always outputting the estimated number of ice creams. Yes, I did. Sweet, 9 marks. Pretty sure I'm already in the top grade territory now, even if I get everything wrong from now on. Alright, off, off, on, off, 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 on. Off, off, on, off, off, on, correct. On, off, 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 on. On, off, off. Crap. On, off, 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 on. Two marks. Okay, what did I do wrong? Let's have a look at this. Should have checked these actually. Rechecked all these because these were the easiest to make mistakes in, to be honest. Alright. So I said 4 is on. So for A, From A is 0 to 2, switch A. So it's on, off at the start. I'm happy with that. B is 8. Range off from 4 to 6. Oh, B is 8, not 4. So I did the neighbor wrong. Yeah, because I was saying it's strange that the neighbor wasn't changing. Yeah, okay. I accept my mistake. Okay, next one. On, off, on, off, off, on. On, off, on, off, off, on. 4, 4. So for example, we can do so it's really up to us to just judge whether this actually works. Well, let's look at it again then. So switch, neighbor, and range off are used. Switch, so I said switch 1. Let's turn it off. It's neighbor 0 to turn that off, and then range 1 to 7. So that would do 2 to 6. I think that's 3 marks then. I don't think that's wrong. That's it. I did better than expected. I mean, I got more marks than I thought. I thought I would lose more. How many did I lose? 3. And to be honest, the pixel one, I could have lost that. I can't really tell. They seem to... Even if I lost it though, it's not going to change my grade much. Yeah, you know what? That thing I said at the start was wrong, wasn't it? Because triplet of values, that doesn't have to be 0 to 255. It can be... You can have different ranges, so that's false. It doesn't have to be RGB. It could be... There are other systems used, so that's also false. And they don't have to be primary colors. There's no... Oh. Yeah, you know what? I don't think I got that mark. The only relevant thing I have is representing a color, and I don't think they really allow you to say representing a color. I think they want you to point out that it's a unit of some sort. Unit, element. Yeah, I don't have any alternatives to the word point. Okay, I'm gonna dock that mark. We'll be harsh. So we got 76, which is good. So that's on the way for top grade. It all depends on what we get on paper 2 tomorrow. So, what do I think? Overall, I'm actually impressed. This is okay. So when I didn't know what to expect for the content of the computer science course. My worry was that it might be too much like IT and less about science. But from what I've seen, it is actually pretty close to computer science. Just like at a more basic level than what you learn in university. But I mean, you cover logic gates and algorithms. So this is good content. I'm actually pretty impressed. This is what I was hoping computer science would be. In fact, I don't really have any complaints. The trace tables, Maybe there's something I'm not understanding there. Maybe there's a specific way you're supposed to do trace tables that I don't know about. If so, fair enough. But it's ambiguous, I think. The way I understand trace tables, I think what they're asking for was ambiguous. The algorithms section is actually, I think, really good. Like, this is what I would want to see students doing, writing pseudocodes or flowcharts. And they're doing that, and then they're testing them on that, so that's awesome. So this is a really cool course. I wish I had it when I was a kid. And this is a solid introduction to programming when you're at that age. Like, it really is. Like, if you can understand these pseudocodes, you don't need to know how to code in C++ or Python. If you can understand these pseudocodes, you're already halfway there. And you'll be ready for it when you actually do take a course in a specific language. All right. Well, tomorrow I'll do the next paper. I don't know if it's a different topic in computer science, so I don't know what that's going to be about. It's only 2 papers for computer science. All right. Well, see you tomorrow.